G'day all. I thought I would do a little bit of a chat today about climate change and how we know that it's happening. I don't think a lot of people who watch my videos are denying that climate change is happening, but what they might be doing is encountering people who do deny it. I do have Facebook friends who will argue with me about it as well. So I thought what I'd do is just talk a little bit about how we know that it's happening and that human activity causes it. So I think I've probably actually talked about some of this as a walk and talk in the past as well. So apologies if I'm covering some of the same ground, but hopefully this is a lot less bumpy and a little bit clearer. I'm also testing out a new camera and a new environment for talking in, so you can give me some feedback about the aesthetics of the thing as well as the actual content. So very briefly, there are a number of possible explanations that are given for why the climate is changing in the way that it is. Clearly it is changing. It's getting hotter. If you're under the age of 34 years old, you will have experienced 0 or 1 below average temperature months. Every other month in the past 34 years has been above average temperature since records began. So it is clearly getting hotter. The 10 of the 15 hottest record years ever have been in the last dozen years or so. It is hotter globally. Now that doesn't mean that it's hotter everywhere. It's distributed unequally. Yes, there are parts of Antarctica where the ice is getting thicker and other parts where it's getting thinner. But net across the globe, it's called global climate change, not local climate change, and not local weather change. Yes, it will still get cold in places, it will still get a lot of rain in places, but there'll be drought in places, and so on and so on. So it is changing. I don't think anybody really now is denying that change is happening. The changes are happening, they're real. So the people who were denying that there was anything, and they will still say, oh well, the hockey stick graph that Michael Mann made was a flawed graph. So that unfortunately is, the first version was probably incorrect, but if you look at any graph now, it has that hockey stick shape, because that's what's happened to temperatures in the real world. So trying to make sure that that actually is made clear, that there's no point denying that the climate is changing. So then once you've got the notion that it's changing, why? Well, so the one common explanation is the sun's behaviour. The sun does fluctuate in its heat. It fluctuates in sunspot activity, and that's somehow correlated with its energy output, although we don't 100% know how. At the moment it's a very, very low sunspot minimum, which tends to correspond with a low solar energy output. So that tends to lead to less solar energy rather than more, and cooling rather than heating. People will talk about it's been cold in the past, and there have been minima in the past. There have, but they've been local. So there was a period where you could ice skate on the Thames for a couple of years in a row. And there was the medieval warm period, which is a warmer period, but again, in Europe, not globally. So those local things probably relate to changes in ocean current flows and so on. We haven't seen warming at this rate and on this scale ever since records were kept, and probably not even in ice core records. There have been very large changes in global temperatures, but they've taken place over much longer timescales than the 100 or so years that have happened most recently since we started digging up fossil fuels and burning them. It's basically an unprecedented rate of heating, and it correlates with that activity, but it's not just correlation. There is a really clear mechanism that explains why it's happening. So back to the sun for a second. So the sun is actually at a minimum rather than a maximum, so you would think it would actually be not contributing to warming. And there have been various studies by people who specialise in the sun, and they've said at an absolute maximum, changes in the sun could contribute less than 40% of the observed warming. It's probably much less than that. It may be none, it may even be counteracting the observed warming, but at absolute maximum, it could contribute 40% of the warming, and the rest of the warming has to come from somewhere. So it's not the sun. It's very likely to be, it's not also urban heat islands. There's this common myth that temperatures as measured by scientists are rising because the thermometers are in cities, and cities don't reflect light as well. They reflect heat as well. They actually hold it. So overall, the measurements by scientists will increase in temperature over time, although the globe itself isn't increasing. That's also a myth. It's also nonsense. The sensors are in a much wider range of environments than that, and scientists know how to calibrate for that. Of course, if you're a conspiracy theorist, the fact that they are calibrating itself is evidence of dishonesty, and there's a whole other conspiracy theory narrative around that, around people tinkering with the temperature record. But if they're tinkering in that way, it's usually to lower the numbers rather than to raise them, because they're recognising the urban heat island effect. So there is not a big conspiracy of climate scientists to fool us. The other issue, which is conflated, and I think I'll make that a separate video because this one's already getting long, is it's a UN or a globalist or a Jewish or a banking conspiracy to bankrupt the rich countries and steal all our money and turn us communist. And the newest one I've heard is that it's a papal conspiracy by the Catholic Church to make us all worship on Sunday so that we have Sunday off and don't produce greenhouse gases on one day a week and therefore reduce things. The level of conspiracy thinking that goes into it, I use the word thinking advisedly, that goes into a lot of these claims is quite worrying. So let me just really clearly explain the mechanism. Basically, we get all of our energy from the sun, the vast majority of our energy. There's some from nuclear and a few other things, but the vast majority of energy on Earth arrives from the sun as ultraviolet radiation and visible radiation. So they are both quite short wavelength, quite high energy forms of radiation. They come in. About 30% of what we get from the sun stops at the upper atmosphere. It's just reflected off the atmosphere itself without ever getting into the atmosphere. Then another 30% is absorbed by the atmosphere on the way in, and about 40% hits the Earth's surface, and then bounces off. Say if you are over an ice field, where it's very white and very shiny, a lot bounces off. If you're over black soil, not a lot bounces off. If you're over a rainforest, not a lot bounces off, it gets absorbed. So that short wavelength, high energy radiation has a lot of capacity to do work. It has the power, for example, at the very short end, the ultraviolet end, to give us sunburn and to do a variety of other things to us that we don't particularly like. That's the really high energy end. The visible, obviously, we use it to see by, but it also drives photosynthesis. So photosynthesis creates all of the energy in plants that we then either eat the plants, or we eat animals that eat the plants, or we eat animals that eat the animals that eat the plants. And so basically our energy for us comes from the sun. Basically everything we do is solar energy. Incidentally, fossil fuel energy is also solar energy. People sometimes talk about fossil fuel energy like oil and gas and coal as dinosaurs, old dinosaurs. It's really not. It's really mostly vegetation, because there was vastly more vegetation by mass than there were dinosaurs. There's probably dinosaurs in it, but it's mostly old plants. And those old plants got their energy originally from the sun. So it's kind of fossilized sunlight, really, fossil fuels. The trouble is, it's the sunlight from a very long period of a very high growth period of Earth's history, all collected and now being all released very rapidly in 100 years. It might be 50, 100, 200,000 years, a million years of recorded, of fossilized sunlight, all being released at once. So those greenhouse gases are getting out there. They're being released as energy, but the energy release is not what's hitting the atmosphere mainly. So all that solar energy comes in. If it only came in and didn't go out, we would burn very, very quickly. We would fry, because we need an energy balance for the planet. The energy balance needs to be basically zero. That is, as much goes out as comes in. Otherwise, we get hotter and hotter. Or if it were more goes out than comes in, we would get colder and colder. So we want that energy balance to be pretty close to zero. It has been historically pretty close to zero. It's gone up and down. We are currently in a relatively stable period of relative warmth. The last 12,000 years, we haven't had an ice age. It's been relatively warm and relatively nice for humans to live. But what we're actually doing now is changing that energy balance. How are we changing it? Because particular gases absorb the the infrared, the very long wavelength, low energy radiation that is at the end of all energy processes. So basically heat energy radiates out in the form of this infrared radiation, which we can't see. It's long wavelength, low energy, and it doesn't have enough energy to do any useful work. It's just heat, and it radiates off into space. And we want it to radiate off so that we have our energy budget close to zero and we don't get hotter and hotter. But what's happening now is those long wavelength radiations are absorbed by certain molecules in the atmosphere. Now, the atmosphere is mostly nitrogen, about 80% nitrogen, about 20-ish% oxygen, which we breathe, and a bunch of trace gases. And a couple of those trace gases are the chlorofluorocarbons, which we have banned since the Montreal Protocol of 1990, so we're not still producing chlorofluorocarbons, but there are a bunch of them still in the atmosphere. So they're a greenhouse gas, as well as damaging the ozone. They do two different things. Damage the ozone layer, which allows more ultraviolet to get in, and they act as greenhouse gases. They absorb the infrared on its way out. But the main two that we're really worried about are carbon dioxide and methane. They both have carbon in them. Carbon dioxide has a carbon with an oxygen on either side. Methane has a carbon with 4 hydrogens all around it. And they both vibrate in their molecular structure in a particular way that will absorb that infrared radiation and then re-emit it, either by heating up surrounding gases or by re-emitting it as another infrared photon in a different direction. So they tend to keep the heat in the atmosphere instead of letting it out. They really do what a greenhouse does for plants, which is a glass house that keeps the heat from getting out, or what a blanket does for us. A blanket basically insulates us. It doesn't give us heat, unless it's an electric blanket. If it's an ordinary blanket, all it does is keep the heat that we're creating in our bodies in. And that's what the greenhouse gases are doing to the Earth. They're keeping that heat that we create in by absorbing it into these molecules, which vibrate in certain ways, and then re-emitting it as extra heating of the atmosphere. Some of that heat goes into the ocean, so the oceans are getting hotter as well. The oceans also dissolve some of that carbon dioxide, so they're getting more acidic. There's serious worries about the ocean getting more acidic and damaging the ocean ecosystems that a lot of people rely on for their livelihood and their food. So those two main gases, and carbon dioxide is mainly produced by burning fossil fuels. Fossil fuels tend to make carbon dioxide and oxygen and water when they burn. Water is also a greenhouse gas, but it is not particularly one that we have a lot of control over because it's naturally part of the weather system. And methane is largely produced by agriculture, by cows and sheep and the way they digest. There's another talk to be had another time about the fact that kangaroos don't produce methane when they digest. But cows and sheep do. It's the particular mechanism that they use to digest grass. They produce a lot of methane, but there's also a lot of methane locked in the permafrost in northern parts of the world. And that methane is being released as the permafrost heats up, melts. And there are very scary photos of methane sinkholes opening up in the permafrost, methane boiling out of lakes and a whole bunch of things. So there's a kind of a positive feedback. As the climate gets hotter and hotter, more and more methane gets out, the climate gets hotter and hotter still. So that's one of the things we don't have a lot of control over is the melting of the permafrost. We do have a lot of control over our agricultural practices, so we probably should move towards more of a plant-based diet, or if we're going to eat meat, then things that aren't cows and sheep. We should move toward more electric vehicles, more solar energy, a whole variety of ways in which we can actually increase or decrease our footprint, decrease the amount of these greenhouse gases in the atmosphere, and therefore reduce the effects. We can't mitigate them completely, it's too late for that. There will be effects. There will be sea level rise, there will be salination, there will be additional extreme weather events and so on. It's now a matter of trying to make it less worse. There are hopeful things about technology that might help with that, but I think each of us need to, A, do what we can individually, but B, vote for governments who will do things and get out of the way. I think the technology can do a lot. Governments who are in the pockets of fossil fuel producers are obstructing that from happening at the moment, and we need to get rid of them and get some governments that actually will help. So individual action does something, but collective action does more, and this might be a bit of a theme that you've heard from me before. So I hope that's useful. Because I think the other thing that people often say is, oh, well, it's all climate modelling. There's no real science behind it. It's just the computer modelling of this, that, and the other thing. No, no, no. We understand the mechanism really well. We understand these rays of light of this colour, which we can see with our eyes, are absorbed in these ways by these vibrations of these molecules and then released in these ways. We really, really do understand why greenhouse gases cause warming and how they're causing it, and we know that it's happening. So human activity is causing it, and human activity is the only thing we can fix. Even if it turned out the sun was doing 40%, we can't do anything about the sun. We can't turn the sun down. We don't have a thermostat for that. Natural activity that's happening, natural changes, we can't really change. So we need to do things like reducing the level to which we log and clear fell forests, growing more things that actually take carbon out of the air. There's a whole variety of things that we can usefully do, and human activity is really important. So, probably longer than I wanted to talk for, but hopefully useful and interesting. And if somebody tells you that climate change isn't happening, or that it's not caused by humans, make them watch this video. Sit them down, strap them in, make them watch it. Thanks a lot. See ya.